In the vast expanse of our solar system, there exists a peculiar sideways planet that has puzzled scientists for years. Uranus, the sideways planet, rotates almost perfectly on its axis with a slight tilt. But here's the twist. All of its known rings, and at least 27 of its moons, rotate in the opposite direction. They are in retrograde rotation. What's going on here? And more importantly, why? Welcome to my channel. And in this episode, we'll dive into the perplexing phenomenon of retrograde rotation and explore the intriguing theories surrounding Uranus and its moons and rings. You might be wondering what's so unusual about Uranus spinning on its side. Well, most planets in the solar system rotate on their axis with a slight bulge at the equator. Much like Earth, the Earth's rotational speed is so fast that it actually pulls the planet into a bit of a wider shape. This means that if you were standing on Earth, you would be a little bit further away from the center of the planet than if you were on a non-rotating world. But Uranus is different. It rotates on its side with its equator almost perpendicular to the Sun. Scientists believe that something huge has crashed into Uranus in the past, knocking it off its traditional rotation. Now, you might be thinking, okay, so what? Planets can get knocked around? But here's where things get weird. Most of Uranus's known rings and at least 27 of its moons also rotate in the opposite direction to the planet. This means that instead of orbiting Uranus in the same direction that it rotates, they go around in the opposite direction. This is known as retrograde rotation. Let's take Miranda, one of Uranus's moons, as an example. Miranda is a small moon that has an irregular shape and is covered in craters. It rotates once every 19 days, and it does so in the opposite direction to Uranus. In fact, all of Uranus's major moons, except for Ariel, Umbriel, Titania, and Oberon, rotate in retrograde rotation. Now, it's important to note that we haven't observed all of Uranus's moons in detail. So we don't know the rotational speeds of all of them. But the ones we have observed do show this pattern. It's not just the moons that exhibit this behavior. Uranus's rings also rotate in the opposite direction to the planet. The majority of these rings are opaque and only a few miles wide. But the complexity of their patterns adds to the intrigue of Uranus's peculiar behavior. Scientists have come up with various theories to explain this strange phenomenon. One popular theory is that Uranus was once a perfectly round planet that rotated in the same direction as its moons and rings. However, something massive, perhaps a planet or a large comet, collided with Uranus, causing it to spin on its side. This impact would have been so powerful that it would have affected not only the planet itself, but also its moons and rings. As a result, the moons and rings were thrown into retrograde rotation, while Uranus was knocked onto its side. But wait, let's think about this. If the collision knocked the moons and rings into retrograde rotation, wouldn't it also push Uranus in the opposite direction? Wouldn't that mean that Uranus would be rotating clockwise instead of counterclockwise? The answer is yes. So then why doesn't this theory explain what we see today? There are a few possible explanations. One is that the object that hit Uranus didn't just knock it over, but also slowed it down significantly. Over time, the planet would have regained some of its rotational speed, but it never quite returned to the original direction. Another explanation is that the moons and rings were already in retrograde rotation before the collision with the unknown object. In other words, Uranus was not the culprit behind the retrograde rotation, but rather, it was already a feature of the objects that make up the system. For example, the material that makes up the rings could have formed from the debris of a shattered comet. If the comet had been rotating in the opposite direction, its fragments would have retained that angular momentum when they settled into rings around Uranus. Similarly, some of Uranus's moons could have been captured objects that were already in retrograde rotation. Maybe they were asteroids that wandered a bit too close to Uranus and got caught by its gravitational pull. If they were coming in on an angle, they would have retained their retrograde rotation after being captured. But wait, there's another possibility. What if the retrograde rotation is not a result of a single event, but rather a gradual process. Uranus could have acquired its moons and rings at different times, and these objects could have been captured at various stages of the planet's evolution. It's also possible that the material that forms the rings was accreted from a disk of dust and gas that surrounded Uranus in the early stages of its formation. If the material in the disk was already in retrograde rotation, the rings would inherit that property. So how do we figure out which of these scenarios best describes what happened to Uranus? Unfortunately, it's not easy. We need more data and more observations to really understand what's going on. Currently, scientists are analyzing data from the Voyager spacecraft, which flew by Uranus in the 1980s. But we need more. There are several missions that are currently in the works, including one by NASA and one by the European Space Agency, ESA, that will study Uranus in greater detail. These missions will hopefully shed more light on the planet's atmosphere, magnetic field, and its mysterious rings and moons. With more data, we'll be able to better understand the rotational dynamics of Uranus and its moons and rings, and determine the cause of this puzzling phenomenon. And it's not just academic curiosity. Understanding how objects like Uranus evolve can help us better understand the formation of planetary systems in general. And who knows, maybe we'll find evidence of life on one of Uranus's moons. Some researchers speculate that the subsurface oceans of some of the moons could harbor conditions suitable for life as we know it. Imagine that. And if you want to learn more about the fascinating discoveries that await us in our solar system and beyond, make sure to subscribe to my channel. That's because science is full of surprises, and there's always something new to discover. Who knows what other mysteries of the universe will unravel together? Just think about the incredible journeys we've already embarked on. We've explored the strange world of quantum mechanics, where particles can be in two places at once, and the mind-bending realm of special relativity, where time and space intertwined in a cosmic dance. We've journeyed through the vast expanse of our solar system, discovering the hidden gems like Uranus and its rings. But our adventures don't end there. We've even ventured beyond our solar system, exploring distant galaxies and the mind-boggling concept of parallel universes. And as we continue to probe the depths of space and time, we'll uncover even more wonders. Imagine the thrill of discovering signs of life on exoplanets, or the awe-inspiring beauty of witnessing a supernova up close. Picture the moment when we unravel the mysteries of black holes and wormholes, or when we finally understand the true nature of dark matter and dark energy. And it's not just about the incredible discoveries we'll make. It's also about the journey itself. As we explore the unknown, we'll push the boundaries of human knowledge and understanding. We'll develop new technologies and capabilities that will change our lives in ways we can't even imagine yet. And the best part is that you can join us on this incredible journey. By subscribing to my channel, you'll be among the first to know about the latest discoveries and breakthroughs. You'll get to explore the wonders of the universe right alongside with me. So what are you waiting for? Click that subscribe button and join the adventure today. Together, we'll uncover the secrets of the cosmos and push the boundaries of human knowledge. So don't miss out. Subscribe now and embark on a journey that will take you to places beyond your wildest dreams.